In this video, we're going to talk about reference angles. This video is very closely related to the trigonometric functions of any angle video. But in this video, we're going to specifically look at reference angles and then do some examples. So a reference angle for an angle is the acute angle formed by the terminal side of the angle and the x-axis. So it's very similar to how we constructed the reference triangle in the previous trigonometric functions of any angle video. So it's asking us to find the reference angle for the following angles. So the first thing that we need to do is draw the given angle in standard position. Then we need to draw our reference triangle by drawing a perpendicular line from the terminal ray of our angle in standard position to the x-axis. This will allow us to find the reference angle. So we know that 120 degrees is between 180 degrees and 90 degrees. So our angle is going to be located in quadrant 2, somewhere over there. Then we'll need to drop our perpendicular line in order to form our reference triangle. This means that this angle right here, let's just call it theta, is going to be our reference angle. So now, as you can see by my picture, our angle theta is between 180 degrees and 120 degrees. So in order to figure out what theta is, I can simply say theta equals 180 degrees minus 120 degrees. And that gives me theta equals 60 degrees. So my reference angle for 120 degrees is 60 degrees. And we can do the same thing for 210 degrees. 210 degrees is between 180 and 270 degrees. So it's going to be somewhere in our third quadrant. We're going to go ahead and drop that perpendicular line to our x-axis, which means our reference angle, again calling it theta, is that angle located right there. So in order to find what theta is, you can see how we're just a little past 180 degrees. So in this case, I have theta equals 210 degrees minus 180 degrees. That's how much I am past 180 degrees. And in doing this, theta is going to give me 30 degrees. So our reference angle for 210 degrees is 30 degrees. Again, 315 degrees is between 270 and a full rotation being 360 degrees. So we're somewhere in the fourth quadrant. So this is my initial, and I go all the way around to the terminal ray is 315 degrees. Again, dropping that perpendicular line to form my reference triangle. So we can now see this angle here is my reference angle. So looking at my picture, I'm not quite to 360 degrees. So I have my reference angle theta is equal to 360 degrees minus 315 degrees, and that gives me theta equals 45 degrees. So my reference angle for 15 degrees is 45 degrees. Now it's asking us to find the sine of the 6 trigonometric functions of the given angle negative 57 degrees. So remember, as I said in the trigonometric functions of any angle video, depending upon what quadrant you're in, depends upon the sine of the 6 trigonometric functions. So the first thing that we need to do is draw our picture. I'm going negative 57 degrees. And remember, when I have a negative angle, that means I'm going in the clockwise direction. So here is negative 57 degrees. So this means I'm in the fourth quadrant. So now that we know that we're in the fourth quadrant, we want to go ahead and draw our reference triangle. Okay, drawing our reference triangle allows us to be able to see that we have a positive x direction and a negative y direction, and our r is also going to be positive. So the sine of negative 57 degrees If you remember again from the previous video, we said that sine theta equals y over r. And looking at our picture, our y is negative. So that means the sine of negative 57 degrees is going to be negative. The cosine of negative 57 degrees. We said that the cosine of an angle theta is x over r. In our picture, both x and r are positive, so we're going to get a positive answer. The tangent of negative 57 degrees. We said that tangent is y over x. In our case, y is negative, so we're going to get a negative answer for tangent. Then we have cosecant negative 57 degrees. Cosecant is the reciprocal to sine, so that would give me r over a negative y, which is going to leave me with a negative answer. Then we have secant of negative 57 degrees. Secant is the reciprocal to cosine, so we're going to have r over x. Both of those values are positive, so my final answer is also going to be positive. And finally, we have cotangent of negative 57 degrees. Cotangent is the reciprocal to tangent, so we have x over negative y, and that's going to leave me with a negative answer. So as you can see in the fourth quadrant, we have sine and cosecant both negative, cosine and secant both positive, and tangent and cotangent also both negative. This next problem is asking us to find the reference angle and the exact function value. And we need to keep in mind that we may have to correct the sign for the appropriate quadrant that the angle lies in. So for example, if our angle is in quadrant 1, where all 6 trigonometric function values are positive, but the actual angle that we're looking at is in quadrant 4, then as we saw in the previous example, that's going to change the sign of our sine theta and our tangent theta. So we always need to keep that in mind. So the first thing that I always do is draw my picture. Cosine of 150 degrees. 150 degrees is between 90 degrees and 180 degrees. So drawing that angle in standard position, here's 150 degrees. Going to drop that perpendicular line to the x-axis. So here's my reference angle theta. So again, in order to find theta, I need to see how far away I am from that 180 degrees. So I have theta equals 180 degrees minus 150 degrees, and that gives me theta equals 30 degrees. So now instead of trying to find the cosine of 150 degrees, I can simply say, well, what's the cosine of 30 degrees? And if you remember back to the triangles and trigonometry video, we found that the cosine of 30 degrees equals root 3 over 2. But again, we need to take into account the sign depending upon what quadrant we're in. So cosine of 30 degrees is in quadrant 1, which makes the sign of all of the trigonometric function values positive. But we are with 150 degrees in quadrant 2. And in quadrant 2, I have a negative x value, a positive y value, and a positive r value. And cosine is x over r. So if my x is a negative direction, so I have a negative x, this tells me that the cosine of theta in quadrant 2 is going to be negative. So I need to make sure that I change my answer to a negative root 3 over 2. Our second problem says the tangent of 135 degrees. So again, the first thing I'm going to do is draw my picture. 135 degrees is again between 90 degrees and 180 degrees. So drawing my angle in standard position, this is approximately where 135 degrees is located. drawing my reference triangle, I find that this is going to be my reference angle. So again, how far away from reaching 180 degrees am I? So theta equals 180 degrees minus 135 degrees, and that gives me theta equals 45 degrees. So instead of trying to find the tangent of 135 degrees, we can just find the tangent of 45 degrees. Again, remembering back to the triangles and trigonometry video, we found that the tangent of 45 degrees equals 1. But the tangent of 45 degrees in quadrant 1 is always going to be positive. In quadrant 2, which is where 135 degrees is, we have a negative x and a positive y. And the tangent of any angle in quadrant 2 is going to be a negative x over a positive y, which gives me a negative answer. So again, I need to change my answer. The tangent of 45 degrees is a positive 1, but the tangent of 135 degrees is negative 1. All right, our last problem is the cosecant of 450 degrees. So starting to draw my picture, 450 degrees means that I have started at my initial side and I've gone all the way around, and I need to figure out where I'm going to stop. So the first thing that I'm going to do is I'm going to do 450 degrees minus 360 degrees. I'm going to take out a full rotation in order to figure out, after I make that full rotation, where does that terminal ray end. So taking 450 degrees and subtracting 360 degrees, I'm left with 90 degrees. So by accident, maybe, I actually drew this perfectly. So it's going to make one full rotation, and then it's going to go 90 degrees past a full rotation and stop right there. So really we can say, now that we're looking for the cosecant of 90 degrees. So if you, again, recall the triangles and trigonometry video and kind of remember some of the stuff I've said so far, when we're talking about the unit circle, which is what we work with throughout majority of the semester, when we're talking about the unit circle, that means I have a circle with radius 1. So if I have a circle with radius 1, this point right here, which is our 90 degrees, that point is actually 0, 1, because if my radius, right, which is from my origin to that point, is a distance of 1, my radius is 1, so that point up top here is going to be 0, 1. And if you remember, the x value is my cosine and the y value is my sine. But this says cosecant of 90 degrees. So again, I can rewrite that as its reciprocal, 1 over the sine of 90 degrees is still going to equal the cosecant of 90 degrees because those two trigonometric functions are reciprocals of each other. So now I have 1 over the sine of 90 degrees. And as you can tell from my picture up here, the sine of 90 degrees is our y value, which is just 1. So my final answer, 1 over 1 equals 1. So the cosecant of 450 degrees is just 1. All right, in our final example, we have given that sine of 41 degrees equals 0.6561. Cosine of 41 degrees equals 0.7547, and the tangent of 41 degrees equals 0.8693. And it's asking us to find the trigonometric function values for 319 degrees. So again, the first thing that I always want to do is draw a picture. 319 degrees is going to be located in quadrant 4. So I start with my initial and I go counterclockwise in the positive direction to 319 degrees. I'm going to draw that perpendicular line to the x-axis. So that means that right here, that angle theta is going to be my reference angle. Again, in order to find that reference angle, I need to know how far away from 360 degrees I am. So I have 360 degrees minus 319 degrees, and that leaves me with theta equals 41. So now I know that 41 is my reference angle for 319 degrees. And of course, up here, they gave us the answer of sine, cosine, and tangent of 41 degrees. Again, 41 degrees is in quadrant 1, which is why all of those values are positive. And 319 is in quadrant 4. So all we're really going to have to do is just change the sign of the values that they've already given us. So in quadrant 4, we have a positive x, a negative y, and a positive r value. So we would have the sine of 319 degrees. Remember that the sine is y over r, but here my y is negative, so my answer must be negative. So if my reference angle is positive, my value for the sine of 319 degrees must be negative. So looking at the answer for the sine of my reference angle, I'm still going to get the same answer, it just has to be negative. So we're going to get 0.6561. Cosine of 319 degrees. Remember, cosine is x over r. Looking at my picture, both x and r are positive. So in this case, we're going to get the exact same answer as my reference angle, which is positive 0.7547. Then I have the tangent of 319 degrees. Remember that tangent is y over x, and in quadrant 4, y is negative. So that's also going to give me a negative answer. So I have negative 0.0693. So you can see how we can use the answers given to us by our reference angles instead of trying to find our trigonometric function values for a given angle. We can use these known values for 30 degrees, 60 degrees, 45 degrees of our reference angles and still have the same answer, but all we have to do is make sure that we are changing the sign depending upon what quadrant your given angle is in. And that's all you really need to know about reference angles. Make sure that you watch the trigonometric functions of any angle video, as these two videos are very closely related.